We're going to start with a simple blink program. In order to do that, what we're going to need is a couple of different things. We're going to start off with a Uno. So this has a little microprocessor in the middle of it, you can see there, and you can program this just by a USB port. You can see it's also got a power input. So once you've finished programming, you can then just power the Uno device and it will continue to do whatever you've programmed. We're also going to use a breadboard. So on a breadboard, this is a simple way of prototyping with electronics, and you can see along the top there's a whole lot of little holes, and each of these rows, these 5 pins here that I'm pointing to at the moment, are all connected, and so that means you can put a jumper lead into one and that will then power all 5 of those pins, and so that makes it very easy to wire up because you don't actually have to do any soldering, you can just plug things in. We'll also need an LED. So this is our little light emitting diode that we're going to use for our project, and we're going to make that blink. We'll need a resistor right here, a 220 ohm resistor, which isn't in focus very well. There we go. And then we'll need some jumper leads. And so these are the jumper leads you can see on the end of them. They've just got a little connector that you can then plug straight into the breadboard, which is going to make it very easy to prototype. So once we've got these things, we take our Uno and we're going to plug one of our jumper leads into port 13. You can see each of the ports along the top of the Uno here. All of these ports are numbered. So you can see here I've got port 13, and so I'm plugging that jumper lead into port 13. In order to complete a circuit, you've got to go from one of these numbered ports to a ground, and so you can see across here we've got some G and D ports, which are our ground ports. So we're going to plug a jumper lead into our ground ports. The other end of those jumper leads I'm going to run to the breadboard. So first of all, the brown lead, which I've plugged into the ground, I'm going to plug into this row here on the breadboard. So you can see all of those pins there will now be ground. And the one that I've plugged into pin 13, I'm going to run into the third row there. Okay, so you can see there. With the resistor, if you just run current directly from the Uno straight through an LED, then it will draw too much current and either damage the Uno or it'll damage the LED. So what we're going to do is put a resistor in place, which is then going to reduce the amount of current flowing. So I'm going to go from the ground pin right there, and I'm going to run that into the second row of pins just by bending the resistor a little bit. So I've now plugged my resistor in place, so you can see it's running from the ground row here to the row next to it, row 2. And so I've now got pin number 13 running out of the Arduino into the breadboard, pin number 13 running out of the Arduino and into the breadboard in the third row. I've got the resistor coming from the second row into the first row, and then I've got the ground running back into the Arduino. I'm then going to take my LED, which is right here, and I've got to have a look at the end. So you've got to see which side is the positive and which side is the negative. So a way I was always told to remember is you've got to be more positive than negative, which means that the long end needs to go to the positive, so that not the ground, and the short end goes to the ground. So we're then going to take our LED and we're simply going to put the short end into row 2, the long end into row 3, into place like that. And so we've now got a very simple circuit. We're running out of pin 13 into row 3 here. The LED is jumping from row 3 to row 2. The resistor is jumping from row 2 to row 1, and then from row 1 we're going back to the ground. And so you can see I've got the LED and the resistor both in line in serial with the other things in my circuit. Once you have your Arduino circuit, we now need to plug this into our computer so that we can actually program it. So I've brought this across to my computer. You can see on the side there's a USB port, and so I'm then going to take the USB and I'm simply going to plug it in to the USB port. can see the lights light up, which will now allow me to run the Arduino coding platform, the IDE, in order to program it. Once we are ready to actually code, we need to start the Arduino IDE. You can get that from the Arduino website, and you can see on our screen now that I've got the Arduino IDE open and I'm ready to start typing my code. Within the IDE, you can see there's two sections that it starts up with a blank sketch. So here we've got a setup section. And so this is our first code. This is our code that's going to run when we start our Arduino Uno up. And then the thing that's going to happen over and over and over again goes here within the loop section. So you can see it says when you start a blank project that you can put your setup code in here to run once. So what I'm going to do is I'm going to click on the blank line. And the first thing we have to do is tell the code where things are plugged in on our board. So what I'm going to do is I'm going to type a command called pin mode, and we've got an LED plugged into pin 13. So you can see I've written pin mode, I've put a bracket, and then I've written 13. And I'm going to say that this is an output. Now the program itself doesn't mind what it is you've got plugged in. You just have to tell it whether it's going to be an output device or an input device. So here on pin 13, we're going to have an LED, and that's going to display a light, which means it's output. And you finish the line with a semicolon. So make sure you put the semicolon at the end of the line. And so we've done our setup. We've told it what's plugged into our board. Then down here in the loop section of the program, we're going to turn that LED on, wait a bit, and then turn it off. So the command to turn the LED on is called digital write. Then we say where we want to write to. If you've got multiple things plugged into your board, then you may want to write one thing to pin 13 and a different thing to pin 12. So here we're going digital write, and we're saying to pin 13, and we're going to set the voltage to high. We finish our LED, finish that line once again with a semicolon. Our next command is going to be delay, and that's measured in milliseconds. So we're going to delay for 1000 milliseconds, which is 1 second. Then we're going to turn the LED off. So once again, we're going to digital write, and this time we're going to set pin 13 to low, and so that's going to set the voltage to low. And then once again, delay for 1000 seconds. And so here in our code, we're turning the LED on. We're waiting for 1 second. We're turning the LED off. And we're waiting for 1 second. And so anything that you put after double slashes is a comment. And so you can see here I've explained my code. We're going to turn on high, wait for 1 second, turn on low, wait for 1 second. Now we need to upload that code to our board. So under the Tools menu, we need to check that our board is actually connected. So we go to Tools. You can see that I've got a Uno connected to my computer, and it's on COM3. Generally, the board that you plug in last will be the highest COM port in your list. So if you've got multiple things plugged in, it'll be whatever the highest number is, highest COM port number is. And once you've done that, we just simply come across here to our upload button, and we can upload the code and obviously save it as well. So we're going to compile the search. And I've missed a capital letter. So you can see important syntax is important. So I've missed a capital M on the pin mode. And so it means it didn't know what pin mode was. It didn't understand that command. And so we're going to upload once again. And you can see it's now uploaded to my board successfully. The board flashed a little bit while the code uploaded, and now the LED is flashing on and off. If we want to play around with our code, then we can change these numbers. So if we want it to flash a bit faster, we can make it 500 milliseconds. And when we upload that, you'll see that the LED then flashes faster. By adding extra write and write high and write low statements, you can then start to play around with your LED and make it flash in different patterns.